Eighth graders, this is your math lesson for kind of a change, I guess I would say. I've decided today that we're going to do a little review on yesterday's lesson. So we're going to go to the back of the book, page 732, look at section 4-7 on page 732, and we're going to be doing numbers 1 to 26. I'm going to do some example problems. Some of them are going to look awfully like the problems on 732, and some of them not so much. But we're going to try to get a better feel for what's going on there. Look at the first 6 problems on page 732, lesson 4-7. I'm looking at 1 through 6. That's about 2/3 the way down the page. The directions say write each expression using a positive exponent. So I'm going to look at number 1. Number 1 says y to the -9th power. Y to the -9th power. Well, over here, I'm going to do something similar to that. If I wrote x to the -4th power, what does that really mean? Well, we know that x to the 4th is just simply x times x times x times x, right? And what I tried to get across to you yesterday and today was that negative exponent just simply means put it over the top or underneath the number 1. That's all it means. So x to the -4th is really 1 over x to the 4th. So I've created a positive exponent that is exactly the same value as this. So let's go over here. Y to the -9th. That's really 1 over y to the 9th. It's the same thing. Okay. How about number 7? Number 7, they're saying write each fraction as an expression using a negative exponent other than the number 1. Other than the number 1. And for number 7, they give us this value that they want us to change. They give us 1 over the top of p to the 4th power. 1 over the top of p to the 4th power. Well, this problem is kind of like the reverse of this problem. They're asking you to go from this to something that looks like this, because the directions say they want you to create a negative exponent, right? So, what does that equal? Well, look over here. Here we have the positive exponent working backwards. This is our negative exponent, right? Now, why does that work? Where are we getting that from? Well, if I think about, say, for example, 1 over p to the 4th, which is our problem here, we know that's really 1 over p times p times p times p, right? Right? That's what p to the 4th means. And if I was somehow able to flip that right side up, p times p times p times p. Why do I keep writing double x's? I don't know. That's really p to the 4th power, right? Yeah. So, in this particular case, we think about the reciprocal of that, and we get p to the -4th. That's really what they're looking for there. You might be thinking, well, but how do we get there? How do we get there? We talked about this a little bit today in today's math lesson. If I have, let's say, for example, 3 to the 2nd, 3 to the 1st, 3 to the 0 power, those equal 9 and 3 and 1. Remember that? And then 3 to the -1st would actually equal 1 over 3. And 3 to the -2nd would actually equal 1 over 9. And 3 to the -3rd would actually equal 1 over 27. Where am I getting that from, Mr. Paco? Well, 3 to the 1st is really 3, right? So 3 to the -1st has to be 1 over 3. These are just simply reciprocals of each other when you're looking at the answers. So 3 to the 2nd and 3 to the -2nd, look at those answers, 9 and 1/9. 3 to the -3rd should be the reciprocal of 3 to the third, which is 27. See that? 1 over 27. Now, is there another way to write 1 over 27? Yeah, you can write it like this. 1 over 3 to the third, which is kind of the opposite value at the top of this chart. And this one right here could be written as 1 over 3 to the second. And this one could also be written as 1 over 3 to the first. So that's why it's p to the negative fourth. P to the negative fourth. How about something from 15 to 20 where, oh wait, no, I want to do also number 14. That's a little tricky. Number 14. They want us to create an answer that doesn't have -1 as its exponent, but they want it to be a negative exponent. And they give us 1 over 64. Well, how would I do that? I don't want, because theoretically, I could just do this, 64 to the negative first power, and I could claim that I'm done with that, right? Here, p to the fourth became p to the negative fourth. This is 64 to the first power. I don't see the 1, but I know it's there. 64 to the first power, and it becomes 64 to the negative first power. But they say in the directions, don't do it with a -1 as an exponent. So here's what I'm thinking. I know that 64 is the same thing as 8 times 8, or in other words, 8 to the second power. What if I flip this and make it 8 to the negative second? There, that's one possible answer. 8 to the negative second. Okay, how about something in the area of 15 through 20? 15 through 20. I'm going to do 15. And they want us to take this value and change it into a negative exponent somehow. Well, isn't that tenths, hundredths place value? Tenths, hundredths? Isn't this 1/100th? Yes, it is. And can we think about this as being an exponent somehow? Well, we could talk about it as 100 to the first power, but isn't it also 10 to the second power? Because 10 times 10 is 100. And then I could change that to 10 to the negative second, and now I have that negative exponent they're wanting me to change it to. Okay? How about 21 through 26? 21's not so bad. 21 says x to the negative second, and we're supposed to change the x into 3. So it's really 3 to the negative second. What does that mean? 3 to the negative second really means 1 over 3 times 3, or 1 over 9. So, that's it. That's all I'm doing. Talk to me if you got any questions. Thank you. Goodbye.